Okay, guys, Term 1 Physics Finals Revision. I'm gonna go through the chapters in the order we learned them. So I'm gonna start with chapter 9, then chapter 4, then 1 and 2. Okay, guys, chapter 9, it's about work, and to be honest, pretty easy. So it's chapter 9. Okay. So, guys, the first thing is work equals force times distance. Okay. Let's say you have a mass or block or anything like this. It's the force. And times the distance it moves. Okay. That's your work. What if the force isn't being applied like parallel to the direction of motion? Like this, it's gonna be work equals force times distance times cosine theta. Theta is this angle right here. Guys, by the way, you can cosine theta here, it's 0, so it would be 1, so yeah, it just cancels out. But if you put cosine theta here 0, it still works. Okay, now the work done by the weight, okay, it's equal to m g h. Okay, if it's going down, it's positive. If it's going up, it's negative. And if it's moving horizontally, then the work done by gravity is 0. Okay, guys, this is the first topic in this coming in the exam. Now this question 18 basically summarizes that. Okay, the work done by the weight of the block is 0. Because why? Because if it's moving horizontally, then the work done by the weight is 0. The work done by normal, it's the opposite of the work done by the weight. If it's moving horizontally, it's also 0. Okay, the work done by the pulling force is force, which is 40 times distance times cosine theta. Okay, here it's gonna be 40 times 3 times cosine 60 here, which is equal to 60. Okay, that's that answer. Now the work done by friction is also force times distance, but no cosine theta because it's parallel to the line of action. Okay, work done by friction, the magnitude of friction is 10 newtons, so 10 times 3. But friction, it's moving in the opposite direction, so it's going to be negative 10 times 3, which is negative 30. Okay? Okay, guys, now the next thing is kinetic energy. Okay? The formula for kinetic energy is 1 over 2 mv squared. Alright, guys? Also, guys, one more thing for kinetic energy, if it gives you the thing in kilometers per hour, to convert it to meters per second, you divide by 3.6. It gives it to you in meters per second. Okay? And mass here, it's in kilograms. Velocity has to be in meters per second. Okay, guys, now also the work energy theorem. What is the work energy theorem? Work energy theorem states that the net work, which is basically the total work on all bodies in a system, if it's not a closed system, then it's not 0. Okay, if it's a closed system, then it's 0. Okay, guys, in a closed system, let's say the network, so work done on A plus B plus C. If it's a closed system, it's 0. If it's if the system is not closed, like isolated, it's not 0. Okay? Work energy theorem only works for not isolated systems. In isolated systems, it's gonna always be 0. Kinetic energy is gonna stay the same no matter what. in isolated systems. So the network equals change in kinetic energy. Okay, now guys, I'll solve also a question on this topic. Question 7. Okay, a rubber ball mass 0.8 kilograms is bouncing off a rock floor when it is about to hit the floor, its speed is 3 meters per second, but just as it bounces off the floor, the speed becomes reduced to 2.6 meters per second. Drag and drop the correct answers to complete the sentences below. The kinetic energy of the ball as it hits the ground. So it's at 3. It's about to hit the ground, it's at 3. So that's the velocity. So we do 1 over 2 m, which is 0.8. 0.8 v squared, which is 3 squared. That's equal to 3.6. Okay, guys. Part B, we're gonna do the same thing, but it's gonna be 1 over 2. Mass stays the same, 0.8. And the velocity is 2.6 squared. Solve that, you're gonna get 2.7. The work done on the ball as it is in contact with the ground. The work done is gonna be the change in kinetic energy according to the work energy theorem. So it's gonna be 2.7 kinetic energy final, because it's the final, minus 3.6. 2.7 minus 3.6 is equal to negative 9. Okay, guys? This chapter 9 is really easy. Okay, gravitation potential energy now. Gravitational potential energy is equal to mgh. GH, the same as the work by gravity. But by the way, guys, work by potential energy, if the ball is above the reference, it's positive. If it's on the reference, it's 0. If it's below the reference, it's negative. Okay? And guys, also potential energy is equal to the negative work done by gravity. Okay? They're like the opposite. Work done by gravity is if it goes down, then it's positive. If it goes up, then it's negative. But here they're the opposite. Okay? Now, this, we need it. Why do we need the potential energy? For mechanical energy. Mechanical energy, guys, is equal to kinetic energy plus potential energy. Okay? And guys, in closed systems, mechanical energy is conserved. That's the law of conservation of mechanical energy. So change in mechanical energy equals 0. That means that kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. Okay? Now, guys, I'm gonna go to the quiz and solve a question about this. This question a lot of people asked about it. Question 27. The pendulum. But why's my laptop so loud? Like I feel like I can't hear my own voice. Hope it's clear in the video. Okay. Guys, here, what do we know? We know that mass is 200 grams, which is 0.2 kilograms. Okay, the length of the thing, like the string, is 0.8. So L equals 0.8. It's projected, so velocity initial equals 2 meters per second. And G equals 10. Guys, if you get a question like this, you think it's hard, just write out the given. And also, like, it helps to draw them out. So guys, this is the pendulum. 2 meters per second, it gets pushed like this. And it's obviously, it's gonna go up It's gonna move like this. Okay, now we'll take this as the reference for the height. Here the height is 0. So the height here, we'll take it equals to h. This is the height. Okay, this is the length. And this part, this, yeah, what the hell? This part, okay, is the length. I mean, we'll call it x. Okay, but yeah, height. So what do we know from this? Height equals the length minus x, because the whole thing is the length. Okay, so now let's find the height. How do we find the height? We know that 1 over 2 mv squared v squared initial, because the kinetic energy initial, plus potential energy initial is going to be 0 because the initial height is 0. So plus 0 equals, we know that the final kinetic energy is 0 because it's going to go, it's going to stop, and it's going to come back down. So plus, it's going to be 0 plus mgh. Okay, so yeah, that's what we have now. We have everything except h. So we'll solve for h. So 1 over 2 times the mass, which is 0.2, times 0.2 times v squared, 2 meters per second squared, which is 4, is equal to mass again, which is 0.2, times 10 times the height. But guys, by the way, this dot I mean times, okay? Times the height. You solve this, you're gonna get the height is equal to 0.2. Height equals 0.2. Okay, let's write that here with the given that we have. Height equals 0.2. Okay, now let me erase this first to have the space. Okay, guys, we know that height is length minus x. Okay, by the way, this is the cosine of the angle we're trying to find. Yeah, height is length minus x. So 0.2 is equal to length is 0.8. 8 minus x. Here you're gonna get x equals 0.6. Now guys, they want us to find the cosine of this angle theta. And this here, this is a right triangle. And we know that the cosine of an angle is the adjacent over the hypotenuse. The adjacent here, it's x. So, and the hypotenuse is L. So we know that cosine theta equals x, which is 0.8. So I'll just write x over L. What's not L? X over L equals 0.6 over 0.8, which is equal to 0.75. Okay guys, that's how you get the answer. Okay, that's almost it for this chapter, but in this chapter we have one more thing. It's power. Power is just work over time. Power can also be, this is average power, delta T. Power, instantaneous power, is force times velocity. Okay, and that's it for chapter 9. That's basically all you need to know for that exam, guys. The pulleys, these simple machines, this stuff, you don't need to know it. Okay guys, now let's move on to chapter 4, which is moments. Probably like one of the tricky ones. Like maybe this one or the electricity one was harder, but yeah, this one is a bit harder. Okay, so what is a moment? A moment is the turning effect of a force. The formula for a moment is the force times the perpendicular distance perpendicular, and yeah, just like I'll I'll help you understand this one guys with a question from the quiz. It's in 4.1 quiz, question 12. Okay guys, but while I'm going to the quiz, I'll let you guys know that you should like and subscribe, yeah? Okay guys, question 12. Okay, the magnitude of force F1, so 15, the distance is 0 also, okay? So distance is 0 about A, F1 about A. What's the distance between F1 and A? It's 0 because F1 is on A. Distance is 0, so it's equal to 0. F2 about A, distance is 0, so it's equal to 0. F3 about A, so it's 30 times the perpendicular distance, which is 3, so that's 90. F4 about A, it's 10 times the perpendicular distance, which is 5 plus 2, so 10 times 5 plus 2 equals 70. Okay, the magnitude of the moment of F1 about B. So F1 is 15. And what's the perpendicular distance about B? It's this one. Well, we don't know what it is. We can use Pythagorean theorem to find it because this is a right triangle. So it's gonna be 5 squared equals 3 squared plus x squared. It's equal to 4. So 15 times 4 is equal to 60. Okay, question F. F2 about B. So 20 times 5, 20 times 5 equals 100. Okay. F3 about B. F3 is on B, so distance is 0. It's equal to 0. And F4 about B is 10 and the distance is 2. So I'll go here. 10 times 2 equals 20. Okay guys, now you should understand like how to find the moment of a force. Okay, now this is where it starts to like get hard for this chapter. Rotational equilibrium, okay, is when the moments for the counterclockwise are equal to the moments on the clockwise, like rotating it clockwise. And translational equilibrium is when the forces going up are equal to the forces going down. Okay. Also, guys, you should know the formula to calculate the center of gravity, which is m1 over m2 times equals G2, okay, over G1. Guys, G2 and G1, these are distances. Let me draw it to help you guys understand. Let's say I have two objects, object A and object B. Okay, the center of gravity of A is going to be in A. So let's say we'll call A1. So this is G1 and this is G2. The distance between them, the center of gravity G of both of them is going to be somewhere between them. So G1 is the distance between G and G1. G2, it means the distance between G2. So these are points on the like figure, okay? And yeah, guys, also be careful, like M1 is up and then GG1 is down, okay? If M2 is down, then GG2 is up, okay? They're not together, okay? Okay, guys, now I'm gonna go to the 4.6 quiz and I'm gonna solve question 2. Question 4.6. Guys, I need some water. Okay, guys, this question. It has nothing to do with what I just solved, but no, it does actually. Yeah, I think. Hope. But yeah, you guys should know how to solve this one, so I'm solving it anyways. Which of the following forces will create a non-zero torque as the object is being flipped? Weight, yes, because the weight is here. Wait, let me explain how it's gonna flip first. Guys, it's an object, yeah? You're pulling it up, and the weight is pushing it down. But it's not gonna rotate here. Like, if it's being pulled up like this, it's gonna rotate like that, yeah? And it's gonna rotate along this point. Right here, the bottom corner of the box. So this is the pivot. It's pivoting along this point. Okay? Now that you know that it's pivoting along that point, you'll understand it better. The weight, yeah, because it's gonna push it down like this. And that has a moment. Tension, there's no tension. This is just pulling the handle. It's not like a rope or a wire. Force F, yeah, that's the pulling the handle. Wait, this is wrong. Friction is gonna be applied like it's not gonna let the ball slide. I mean the box slide. It's gonna be like this. It's gonna prevent it from sliding. But the moment of it is zero. Gas torque and moment mean the same thing. The moment of it is zero because it's on the pivot. So no, and upthrust is when you earn water and the water pushes you up, for example. That is wrong. Okay, now let's solve point B. The smallest magnitude of F that can topple the box. So guys, for the box to topple, you need the force F to be greater than or equal to the force of the weight. So it can like overpower the force of the weight and cause it to like topple over. Now guys, obviously the least thing is if they're equal. So you want the weight, the moment of F, I mean, and the moment of the weight. Okay. So you guys, first let's find the moment of the weight. This is the weight is 60 newtons. They said in the question 60 newtons, and the perpendicular distance is this. It's half the box, so it's 20. So the moment of the weight is 60 times 20. And the moment of the force, it's gonna be 40, because it's this distance. This is the perpendicular distance. Guys, don't get confused and put 35. It's gonna equal to 40 times the force times F. What's that? Times F. Okay, guys, here, shift solve on your calculator. F is gonna be equal to 30. And the answer is 30. Okay. Question 5. Actually, wait, question 5? No, guys, question 5, it's about center of gravity. I'll solve it. Yeah, I'll solve it. Okay. A pen is formed of a spherical tip, mass 7 grams and radius 1. So this tip has a radius of 1. This distance is 1. And a mass of 7 grams. Is attached to a uniform rod. So that uniform rod means the mass, the center of gravity is in the middle of the rod. So yeah, 14 centimeters, or I mean 14 grams and 8 centimeters. So the rod is 14 grams and it's 8 centimeters. Okay guys, so the center of gravity of the tip is gonna be in the middle of it, and the center of gravity of the uniform rod is gonna be also in the middle of it at 4, because it's uniform. Now where is the center of gravity of the pin located from point B? Point B is over here. Okay, so this is the G1, we'll say, and this is G2. The G1 is the center of gravity of the rod, G2 is the center of gravity of the tip. Okay, now G is going to be somewhere in between. Okay guys, so we know the formula to find gravity is m1 over m2. m1, so the mass of this, so 14 over 7 is gonna equal GG2, so this distance, over G1, so this distance. Guys, we'll call this distance x, okay? And we'll call this distance, this is 4 guys, from G1 to this is 5, I mean. So 5, the total is 5. Wait. This is 5. So GG2, so this distance is 5 minus x, so 5 minus x. Why is it 5? Because 4, half of the rod, plus 1, which is the tip, the radius of the tip. 5 minus x over GG1, it's x. So guys, if you do shift solve, wait, let me do it on my calculator. You're gonna get, you're gonna get 1.67. 1. Okay? So x, this distance is 1.67. But they want the distance from G to B. So it's gonna be x plus 4, because this half is 4. So you're gonna do 1.67 plus 4. It's gonna equal 5.67. Okay, that's how you solve this one. It's a bit confusing, I know, it's starting to get hard. Okay guys, but also center of gravity stuff is hard, so I'm gonna solve one more question. I'm gonna solve question 14 in the CQD. I'll scroll down a bit so I'll have more space. Okay guys, the center of gravity of A, B, and C of 3 bodies constituting a system S form an equilateral triangle. So we have, guys, it's for physics, it's always easy to draw out the given, okay? You have A, you have B, you have C, okay? An equilateral triangle side 8, so this is 8, this is 8, and this is 8. Okay, mass of A is 0.3, mass of B is 0.1, mass of C is 0.4. Now guys, when you have 3 bodies, 4 bodies, 5 bodies, just find the center of gravity between 2 bodies and then find that center of gravity with another body. So first, let's find the center of gravity between A and B. So it's G, we'll say this is G, any point, it doesn't matter. We'll just, like, it's not there exactly, but we're gonna use it to calculate. So M1, we'll use the mass of A as M1, so 0.3 over 0.1 equals, we'll take this as x, and this, it's gonna be 8, like this rest of it, it's gonna be 8 minus x. So it's gonna be 8 minus x, because G2, this is G2, over x. If you guys solve this, you're gonna get x equals to 2. Okay, so this is 2 centimeters. Guys, let's erase all of this. So now we know that the center of gravity of A and B, 2 centimeters. 2 centimeters. I won't write centimeters because there's no space, and this rest is 6. Okay, now the center of gravity of A and B, that means the force of A and B is concentrated in here, the G, and the force of this, the mass of A and B, okay, is 0.4, because 0.3 plus 0.1. Now you want to find the center of mass between these two bodies now, 0.4 and 0.4. Guys, okay, so 0.4 over 0.4 is gonna equal to, yeah, we don't know what this length of this is, but guys, basically if they have the same mass, then it's gonna be the same, like I don't know how to exactly find the distance, but it's gonna be in the middle. Okay, it's gonna be in, like, right in the middle. Okay, perfectly in the middle. So guys, basically the center of mass is gonna be here, okay, in the middle of the 2 points. So you'd say like, yeah, okay, like if you want to find this and calculate exactly where in the triangle it is, I don't think they want you to do that, but yeah, this is where the center of gravity would be. Okay, now let's see. Now I'm gonna go to the quiz, because now I need to explain couples. Couples, guys, it's really easy. It's the force of one of them, so 15, times the distance between them, which is 2 centimeters. Here it's in newtons per meters, so times 0.02. 2, you get 0.3. Guys, also if you forgot, you can do 15 times 0.01 plus 15 times 0.01. Well guys, what's the point of a couple? Because some forces, they don't have an axis of rotation. Like you need 2 forces to like cause it to rotate. Let's say you guys are trying to open like a bottle, yeah? You need to spin the cap with both fingers. Like if you apply a force on one part, it wouldn't spin. I mean, it would spin because friction. Like if you like push it with your finger and spin, it's like open because of friction. But yeah, usually you need 2 fingers to open it, like to open the bottle, because it's not stuck in like the axis of rotation. Okay. Now guys, also for this chapter, I'm gonna solve the past paper. This one, question 2 in this past paper, so you guys can understand it even more. Actually, no, before I solve this question, there's another question in the CQD I should solve, this one. But I'll only solve the first part, because the second part, they're just like, you're repeating it. You're repeating the first part. I'll solve this question, then I'll go solve the question in the past paper. Okay guys, a mass 70 kilograms is standing on a plank, mass 100 kilograms, on 2 trestles. Knowing that the plank is homogeneous and uniform, find the magnitude of the vertical forces acting by the 2 trestles when the man is 2 meters away from it. Okay guys, if it's uniform and homogeneous, that means the center of mass of the plank is exactly in the middle of it. So here we have 100 kg, which is 1,000 newtons, because you multiply by g, which is 10, so 1,000 newton. And the weight of the man is going to be applied straight down, so 700 newtons. Okay, find the force. Okay, first Guys, what you're gonna do is you're gonna also use this force, but we don't know it, and this force, which we don't know. Okay, guys, so what you're gonna do is you're gonna take one of these as the pivot, or the pivot. The pivot. Alright, one of these is the pivot. I'll take eeny, meeny, miny, okay, B as the pivot. This is 700, guys, not 100. 700. Okay. B as the pivot. So that means the force on C, the times the moment of C. Oh, guys, I'll tell you what we're using. We're using for rotation, the equilibrium moment of the counterclockwise is equal to the moment of the clockwise. Okay. Here, this is the counterclockwise, and this is the clockwise. Wait, no. This is the counterclockwise. It doesn't matter, okay? Okay, guys, so the force of C times the perpendicular distance, because we want the total moment, which is 3, equals 700 times 1, because that's the distance between the man and B. Okay, times 1 plus this force of the weight of the plank, which is 1000, times the distance here, it's 1.5. Okay, guys, you solve that on your calculator. You're gonna get that it's equal to 733.3. 733.3. Okay, now wait, let me write it up here. Force on C equals 733.3. 733. Point. Bro, can I write properly? 0.3. Okay, now let me erase this to solve for B. But guys, for B, you don't need to find the moments and all of that and go through all that hassle. Look, now because we have one of them, we can do the force up equals the force down to prevent translation motion. That means it's in translational equilibrium. So the force up is 733.3 plus the force on B, because these two are the forces acting up. Force at B equals 700 plus 1000. Okay. Now this is very easy, just do it on your calculator. You're gonna get F of B equals 966.7 966.66.7. Okay, guys, now points B and C and all these points in the question, you're just moving the man around. Okay, you're gonna solve it the exact same way. You're just taking him from here, putting him here, putting him here. Okay, I'm not doing all that. Now, guys, I'm gonna solve this question in the past paper. Okay, define a moment. A moment is the turning effect of a force. Oh, what the heck? This is the turning effect of a force. You guys know that. Okay, on figure 2.1, mark the position of the center of gravity of the meter ruler with a point labeled X. Label the distance of X from the 0 centimeter end of the ruler. Okay, a balanced uniform ruler. That means the center of gravity is in the center of the ruler. And it's a meter ruler, so it's 100 centimeters, so it's 50 centimeters. So it's going to be somewhere after the 42. So this is X, its force is going to be applied down like this. And this distance is going to be 50 centimeters. meters. That's basically what they want from you in part BI. BI. Oh no, there's no part BI. Okay, part C. I show the mass. Show that the mass of the meter ruler is 0.81. Okay, guys, here there's no translation equilibrium because it's balanced. So here we're gonna have to do the. Why is it so like dark? Use like the light icon. Okay. So yeah, the mass was here, and we don't know it. Okay, so let's find the moment of all the forces because we're gonna use moments of the counterclockwise equals moments of the clockwise. Okay, the counterclockwise moments, so the ones going like this are this one, and these two are going counterclockwise. Or these two are going clockwise. This one, it doesn't matter. Okay, they're all going in opposite directions. Okay, I'm confused with stuff. I don't want to think about it every 2 seconds. So 0.34 times this distance, which is 32. So, well, there's no space in this past paper, like it's always. I'm gonna erase it. Wait, no, all of that. Wait. This is gonna get. Okay, this is 0.32 meters. Oh, you don't need to convert because the meters are gonna cancel out. So 32 centimeters. So 32 times 0.34 is gonna equal. This is gonna be 8 centimeters between this and this, because this is at 50, so 8 centimeters times x, so we'll just keep it as 8x plus this force, which is what's 80 minus 42, 38 plus 38 times 0.12. Okay, now guys, when you solve this, you're gonna get that x equals 0.79 newtons. 0.79 newtons. But they want us to show that the mass of the meter ruler is 0.081. How do you find the mass when you have the newtons? You multiply, or no, divide by 9.8 over 9.8. But these past papers have no space to explain. You're gonna get, yeah, approximately 0.081. You're gonna get 0.80 something, 0.080. But the answer is, yeah, you round it up to significant figures, 0.081. That's for part C, I. Calculate the density of the ruler. So we know that the mass is 0.081. 0.081. What's density? Mass over volume. What's the volume? The volume is, oh yeah, it's a lot of like numbers, bro. 6.0 times 10 to the power negative 3. Basically, guys, mass over this times the 0.1 meters, because yeah, and then you're gonna get the answer. I don't want to waste my time like writing it. You guys will multiply this by this by this and do 0.081 over the answer. Okay, I think that's it for the moments. I think that's it, yeah, for the moments. So I'll go now and now let's go to chapter 1. Chapter 1, it's probably the easiest one. It's about the heat transfer and all of that. Okay, temperature, guys, what's temperature? It's equal to average kinetic energy, how fast the particles are moving. That's what temperature is. Thermometric properties that can be used to measure temperature, that type of stuff. Calibrating, ice point is at 0 degrees, you put it in melting ice. Steam point at 100 degrees, you put it over boiling water. Like 1 Kelvin equals degrees Celsius plus 273 plus 273 Okay, guys, also you need to know pressure law, Boyle's law, Charles law. So pressure law is P1 over T1 equals P2 over T2. Okay, Boyle's law equals P1 V1 equals P2 V2. Okay, Charles' law is V1 over T1 equals V2 over T2. Okay, guys, now thermal properties of stuff like the specific heat capacity and that. So we know that Q equals MC delta T. C is the specific heat capacity, the amount of energy it takes to raise the temperature of 1 kilogram by 1 degree Celsius or 1 Kelvin. It's the same, you can use anything. For this one, guys, for this formula, you don't have to convert from degrees Celsius to Kelvin, but for pressure's law, Boyle's law, and Charles' law, you do. Okay. Now, guys, also we have molar heat of vaporization and molar heat of fusion. So Q equals M times latent heat of vaporization. And what molar? I meant latent, guys. Latent heat of vaporization, also Q equals molar heat of fusion. Okay, and this latent heat of vaporization, latent heat of fusion, it's the energy to change the state of 1 kilogram without changing the temperature. Okay, guys, now heat transfer, my favorite part to explain. Conduction happens because of free electrons. The free electrons, they have kinetic energy, yeah, they're moving. They hit another electron, they transfer that kinetic energy. Okay, that's how it happens by conduction. Conduction happens in solids, liquids, and gases when two objects are touching each other. Okay, here it's conducting heat. Okay, metals, they have higher conduction, they conduct more, like they conduct better because they have more free electrons. Okay, now guys, convection happens in fluids. You have the hot, you have the cold. Okay, why does convection happens? Because the change in densities. Hot objects are less dense than cold objects, so the air or water or any fluid, any like liquid or gas, flows up, becomes more dense, flows down, becomes less dense, and loops over. So guys, it also happens like this. This is what the current looks like. Less dense goes up, gets cooled, goes down, and then it loops. Okay, guys. Also, one thing you should know about this is air is actually a bad conductor, but because of convection, like the heat is spread out in it. Now, guys, this is why we use double glazing. It's like two glasses close to each other, or anything with small air pockets. Really, the convection can't happen, and air is a really good insulator. So yeah, nothing can pass through other than radiation, which we'll get to now. Uh, okay, guys. Now radiation, heat transfer by radiation. Uh, yeah, radiation, electromagnetic waves. It's the only way of heat transfer that can happen in a vacuum. It can happen in anything, okay? Vacuum, air, liquid gas, everything. Solid heat. Okay, now guys, the one thing you should know is that black objects, okay, they take in the heat and they store it and they emit it. Like that's why black objects are hotter. You touch them, they're hotter. And the white objects, yeah, they just reflect all the heat. Heat comes in, it gets reflected. Heat comes in, it gets reflected. Okay. Now, guys, to help you to understand that last bit about the heat, there's another question in this past paper, I think. Yeah, this one. Okay, container A has a dull black outer surface and container B has a shiny white outer surface. A and B both contain very hot water at time equal 0. The temperature of the water in each container is equal. State which container has a larger temperature over the first 5 minutes. Container A is going to have a larger temperature because it's dull, it's black. It's going to be hotter. Okay, it takes in more heat. After 30 minutes, the temperature of water in A remains constant. State in terms of energy transfer why energy remains constant, because it's at thermal equilibrium. The energy on the outside is equal to the energy on the inside. So we're gonna say the same. The experiment is repeated without the lids on the containers. State the name of the additional method of energy transfer that can occur. Convection, because now there's no lids, air is going in, air is going out, the convection currents are happening. Part B shows a metal pan with a wooden handle. Why? Explain why there is a much greater rate of transfer of energy through the metal than through the wood. 3 marks, guys, so you need to say 3 things. Metal is a good conductor, that's one thing. Why? Because it has free electrons. Why? Why do the free electrons make it a good conductor? Because they help transfer the average kinetic energy, which is the temperature. Okay, now guys, now we move into, my opinion, like, yeah, it's chapter 2. It's a pretty hard chapter. It has a lot of formulas and a lot of things you need to know. I'll slow down for this chapter, okay? Guys, then, yeah, okay. So guys, first formula is Q equals N times E. Okay? E equals 1.6 times 10 to the power of negative 19. N is the number of electrons and Q is the coulombs. Okay, now electric force between two objects. F equals K Q1 absolute value times absolute value of Q2. Q1 and Q2 are the charges of the two objects over the distance squared. K, it's a constant. It's equal to 9 times 10 power 9. Okay, guys, now the formula for electric field is E, which is the electric field, equals force per coulomb, force per unit charge. Now, guys, the electric current I equals the charge in the coulombs over time. It's basically the rate of like charge flown per unit time. The rate of how fast it is. Basically how fast the charge is moving. Voltage, guys, you should also know this formula. Voltage is work per coulomb. Okay, so basically the work per unit charge. Also, guys, power equals I times V. Power, guys, you should also know is work over time. Which means if you want to find the work, it's just, oh wait, no. Power is work over time. You guys should know all these formulas. This one comes a lot. This one came like in one question. This one, like you guys should know it, but I never saw, like I didn't see a question that didn't come before. This one, yeah, this one you guys should know all of them, okay? Guys, also work is power times time based on this question. Like, you just take time to the other side. Okay, these are all the formulas for charge you guys should know. You guys should know all of these. Take a screenshot, take a picture, you know, anything. Now, guys, the formulas for a resistor. Okay, we know that V equals I times R. That's Ohm's law. Ohm's law. Okay guys, Ohm's law is basically that the voltage and the current across the resistor are directly proportional and the constant of proportionality is R. Okay guys, how do we find the resistance of a wire? Resistance of a wire equals rho, which is a constant for each resistor. They're gonna give it to you in the exam. They're gonna give you like the constant of how resistive this material is, okay? Times length over the cross-sectional area. Okay, let's say you have a wire. Let's say this is a wire. The cross-section area is if you cut it like this is gonna be the area. And the area is gonna be, you guys know the area of a circle is pi r squared. They might give you the area, they might just give you the area. So the resistance is the constant, the length of the times the length of the wire over the area. Okay. Oh, power of a resistor. Okay, power of a resistor. The formula for these is Ri squared or P equals V squared over R. Okay guys, now these two formulas, basically, if you don't want to do Ri squared, like if you have I and the resistance, just use Ohm's law, find the voltage, and you can use P equals I times V. Way easier than doing Ri squared and V squared over R. Just find I and V and use this. If you have voltage and resistance, you can find I. If you have resistance and current, you multiply them, you get V. And then you just do P equals I times V. By the way, guys, these formulas, you just substitute, like, let's say this one, yeah? You substitute V into, like, substitute I times R into V. So it should be I squared times R. You get it, guys? So, yeah. They both come from this. This one gives you both of this. Okay, now if you want to find the work of a resistor, you just multiply the power times time. So you get any of these, you multiply them by time, and you get the work of the resistor. Like the energy loss probably is gonna be probably lost as heat. Guys, that's the energy loss. That's what I mean by energy loss. Like, you know, when you touch something hot, like when you touch a wire, it's hot. Sometimes you touch a battery, it's hot. You know, that's the energy loss. Okay, now guys, the potential difference across a battery. Guys, let's say this is a battery, yeah. If you read it like this with a voltmeter, let's say there's a voltmeter here. You read it, it's not applied to a circuit, then it's gonna give you the voltage, let's say 12, okay, 12 volts. Okay, now guys, if the battery, if it's connected to a circuit, let's say you have like a lamp and stuff, okay, it's gonna wow, wait, it's gonna lose some energy. The battery is being used, it's gonna lose some energy to heat. Okay, now E is the electromotive, like I'll give you the formula. Electromotive force E equals R. I mean, what? No. The voltage, the potential, like, I don't know how to explain it. The energy loss, basically, the voltage loss, okay, is equal to the energy, like, not energy, bro. Electromotive force minus the resistance of the battery times the current. Okay, guys, this is so confusing. But yeah, just memorize this formula, or yeah, I think that's. Now, guys, let me like solve a few, like not solve, explain a few things. Okay, let's say you have a battery. Okay, and this battery, it has 3 resistors connected to it in series. Okay, this, let's say 10 ohms, this, let's say 20 ohms, this, let's say 30 ohms, and the voltage here is 12, and there's a current going. How do you find the voltage at each one of them? So guys, the voltage is going to be voltage of the 10 ohm one. It's going to be 10 over the total voltage, so 10 plus 20 plus 30 over 60 times 12. Okay, voltage of the 20, it's going to equal 20 over 60 times 12, and the 30 is going to be 30 over 60 times 12. Now guys, what if it's connected in parallel? Okay, let's say, yeah, here you have one of them, here you have another one of them, and here you have, I'll draw it down here to finish the rest. Here you have another. Okay, let's say this, and we need to close the circuit. Okay, let's say this is 10 ohms. But damn guys, I want to sleep. I'll finish up the video for you guys, okay? Just for you guys. So you better sub, yeah? Or else I won't forgive you, yeah? And this is 30 ohms. So 12 volts. So guys, we know in parallel the voltage is equal. Now how do we find the current at each one of them? The current in parallel, it divides. So how do we find the current at this one? It's gonna be V over R. So V is 12 over 10. 12 over 10. At this one it's 12 over 20. Over 20, and here it's gonna be 12 over 30. Okay guys, I hope these like few examples helped. Now guys, I'm gonna explain like, okay, I'm not this isn't explaining guys, this part is memorizing. Okay, let's say you have a circuit, current in series. Let's wait, let me just draw like two batteries also, so I can, you know, or two lamps. 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 Okay. So in series, current is the same. Current is equal everywhere in series. Current is I. What a weird I. I was drawing a C, but it's okay. Current is equal everywhere. Voltage, it splits up not equally, just divides across the circuit. So divides across the circuit. I'm not gonna write all of that. Divides across the circuit. Okay. Resistance is you add them up. So resistance total would be R1 plus R2. Okay. Now in parallel, okay, current is equal in parallel. I mean, it splits, current splits in parallel. Voltage in parallel is equal. That's why when we measure using the voltmeter, we measure in parallel. Okay, and resistance total is equal to, you can't find, just do resistance total. In parallel, you do it 1 over R total is 1 over R1 plus 1 over R2, and so on, depending how many things there are in the circuit. Okay, now guys, one more. I'm gonna now. I explained almost everything that's coming in the exam, so I'll just solve a question on this, and yeah, a question about this. So question 7, I think, in this past paper. Question 7, yeah, this question. Okay, guys, figure 7.1 shows a circuit including a 12-volt battery and two identical lamps. The 12-volt battery consists of cells connected in series. Each cell in the battery has an electromotive force of 1.5. Guys, this one's really easy. Total is 12, each one is 1.5. 12 over 1.5, you get 8. That's your number of cells. Okay. When the switch is closed, the ammeter is reading 2.4. Calculate the total resistance. V equals I R. V is 12. I is 2.4 times R. Solve for R equals 5. Resistance is 5. Okay. Each lamp has a resistance of 3 ohms. Calculate the resistance Q. So each lamp is 3 ohms. Okay. 3 ohms. So this is 3 and this is 3. They're in parallel. How do we add them up? 1 over 3 plus 1 over 3 equals 1 over R. Oh, wait, 1 over R. This is the resistance across the two lamps. Okay, guys, let me drink some water, bro. Honestly put. So 2 over 3 equals 1 over R. Flip them both, so 3 over 2 equals R. Okay, so R is basically 1.5. No! Oh, okay, alright. So we know that the resistance across both resistors is 1.5. The total resistance is 5. So this is 1.5 and the total is 5. So 5 minus 1.5 gives you 3.5 to get Q. Okay, guys. The total resistance in the circuit, no, we solved that one. So find the resistance of Q, yes, 3.5. On figure 7.1, draw the symbol for a voltmeter that met the... On figure 7.1, draw the symbol for a voltmeter that measures the potential difference across the two lamps. Potential difference is gonna be like this, the voltmeter. Or you guys can draw it up, it doesn't matter. It has to be with the V. Or you guys can draw it across, it doesn't matter, it just has to be connecting from before this to after this. And obviously don't draw it like, okay, like this, up, down, doesn't matter how you draw it. Like basically I draw it like this, okay, if you guys, okay, this works. The other ones also work, everything works. Not everything, but like, you know, you get the point. Calculate the power supplied to one lamp. Okay. The resistance of this lamp is 3. The current passing through that lamp is, oh, do we have the current? Yeah, 2.4. What was the current? The current is 2.4, yeah. But 2.4, it's for both of them. It's 2.4 here in the circuit. Right, guys? Don't make this mistake. 2.4 here. But they said it's identical lamps. So the current splits equally between them. So it's going to be the current is 1.2. And how do we, you guys know, we can find from the volt, the resistance and the current. It's Ri squared. So 3 times 1.2 squared. 2 squared. That's equal to 4.3. Okay. So the answer is 4.3 watts. Okay, guys, that's it. Like, that's basically almost everything that's coming in the exam. And yeah, good luck in your exam, guys.